Hello guys. I haven't been doing this for 3 days because it's close to Christmas. I want to spend a bit time with my friends, so I haven't do it for like around 3 days. But today I'm back. We're going to do the first unique character and the valid anagram. So for this one, it's very self-explanatory for any string. We just want to find the first non-repeating character and return its index. And if it doesn't exist, we return -1. So the first thing that comes to my mind is that we can check for each character in a string, and we search the first index of that character here and the last index of this character here. If it's equal, then it's a unique character, and we just return it. Basically we just return the index. So like we just need to loop s once, so we just for let character of s we say s dot if s dot index of character is equal to s dot index of last index of, what am I doing, last index of character, then we return s dot index of character, right? So otherwise we return -1. -1 0 0 submit accepted. All right, so but let's see here, it's not the optimal. Here is the optimal, and they use like char code, the Unicode. So let's go back and use the Unicode as well to solve this problem. So basically that the time complexity of this is n and n again here, so it's going to be index of this time complexity of n, so it's n squared. But what we can do is we can use the Unicode one and just search from A to Z, and that way we can just use the time complexity of n. So for we just, but we need a minimal, because what we're gonna do is we're gonna check A to Z instead of from the first to the end. But that's a problem here, because if we can find all the unique values from A to Z, but they are not in order of that string, so we cannot get the index of it. So we need to store the index in a value, the smallest index of unique values in another value. Let's call the value const min, and we give it the initial value infinity. And every time we get a smaller one, we can add that, we can update this. So let's I is equal to 0. Should we char off yeah, we can use char. Oh no, we need to loop through the chart code instead, the Unicode instead. So I is smaller, we have 26 numbers, so it's going to be 97 plus 26 is 1 2 3 1 2 3, and I plus plus and we say the char code is gonna be string method dot from char code, like this. From char code, and give them the char code number. We'll return the char code, and if s.index of the char code is equal to s.index of last index of index of just count type, then we say we update this value, say math dot mean. We say mean or s dot index of -1. Let me think. So if we don't have that char there in S, then it's gonna be -1. -1 is going to equal to -1. So we're gonna get into this. But we don't want it to be in this, right? Because this is gonna be -1. And the main is gonna be -1. And only infinity. If it's infinity, it's not modified. We want it to be index 1, so we don't need this. If this one is equal to -1, we don't want it to get into this as well. So we say this one is not equal to -1. And it's gonna be happening as this gonna be another condition here. So that's it. Then we'll return. We say main if is equal to infinity. Then we return -1. Otherwise, we return to me. Let's run this. Oh, so we need to change that to something that can be modified instead of a constant. Alright. Alright, so this one should be a lot faster because it's time complexity of n. Perfect. Okay, let's go to the second one, valid anagram. So this one, it's just we want to have the same characters in this one and this one, same length, and also each has to be the same length, and also it needs to be the same frequency for each word, right? So false, otherwise true or false. Okay. So the first thing comes to my mind for this one is we can get a frequency counter of this, and then we just use this frequency counter -1 every time we have the same character there. And if the frequency is all 0, then in the end, then we just say it's true. Otherwise, we just say it's false. So firstly, we need a frequency counter here. Const counter is equal to an object, and we pull. Do we need the index number? We don't, so we just say for let char as we say counter char. We say if it exists, we just say plus plus counter char. Otherwise, we just say counter char is equal to 1 character, and then we look through the other char t, right? And we just say counter. Actually, we say if counter exists, if it doesn't exist, then we return false. Or if it's a 0, then we return false, right? Otherwise, we just say counter char. What am I doing? Counter char minus minus. So now we return true. But we need to make sure they are the same length as well, because it could be the t has a smaller length, and even though everything's 0, then we still, like, even though we can pass this, but we cannot return true. So we have to make sure they have the same length. So s dot length is equal to t dot length. Then we return false. So if it's not equal to, we return false. Let's try this. Runtime error length if, don't know what am I thinking. Runtime error, this should be question mark. Alright. Now it's not the most optimal one, but I think it's like pretty much in this area. But we can use again the Unicode to do the checking. That'll be a lot faster. Alright, so if we check the Unicode instead, we need to make an array, and it has 26 letters, and for each letter we have a frequency there, and if for each letter here we +1, for each letter here we -1, and if in the end everything's 0, then it'll be good. So what are we gonna do? So we make the array first. Const counter is equal to a new array, and we have 26 letters. Then we say dot fill 0, make them all 0. And for each char of each character of s. No, we don't do this. We just look through that I is equal to 97, and I is smaller than 1, 2, 3. I plus plus, right? Just like the last one. And if this Let's say the character is gonna be A. The first one is gonna be. All right. Let's get the char code first. Actually, that's not the best idea. We just use. Not the best idea. We need to loop through the S maybe. Then if we do that way, we need to make sure the length is the same as well. So we say if S dot length is not equal to T dot length. Then we just return false first. Make sure they are the same length. And then we loop through 0 and S dot length I smaller than S dot length I plus plus. And we use the counter to count. So if S dot wait, counter. So what we're gonna do is that's the character here, and we want to use that character to add 1 to this counter here, and we want to know the counter's code's index byte. So that's gonna be si dot char code add and then we minus 97, right? So we make sure we plus plus. For the other one, we just say T minus minus, basically like this. Then we need to make sure in the counter dot every character no we just say value val, and val is equal to 0. We'll just return this. Basically, should be okay. Let's see. So this one, the time frequency is just n. Oh, sorry, the time complexity is just n. Oh, a lot faster now. Yeah, I think that's the fastest way to do it. All right, that's for today. We just find 2 methods to solve these 2 problems, and one is using Unicode and is faster, but it's less intuitive in my opinion. Using a frequency counter, it just makes more sense, and it's more general as well, I would say. And because if you use Unicode, you probably cannot check some of the strange characters. We can only search from the range, certain range, and we need to remember the Unicode for that range as well, so probably not the best idea. Yeah, for more readable codes, I think using a frequency counter just makes more sense. But anyway, that one works well as well. Thanks for today. See you guys next time.